Okay, so today we'll start the new topic, which is the stability, control system stability. Okay, so before starting that, let me tell you something that I hope your result will be published. The previous semester result will be published within Saturday, by Saturday. Okay.
What's that?
The previous semester result, which is
Yeah.
which is unpublished.
5 counter number 5.
Because one of you are in the bank, I think. One of our student is in the bank. So let me ensure that is there anyone left for the any previous semester quiz or presentation or whatever else? Anyone missing? Or all of participated in all?
Sir, missing.
Missing means what? Who missed?
Rizvi Ahmed.
রিজভি আহমেদ, তুমি কি মিস করছো?
স্যার ভাইবা মিস করছে স্যার।
কোনটা, মিড না ফাইনাল?
মিড।
আচ্ছা, মিড ভাইবা দাও নাই?
জি স্যার।
আচ্ছা, সেটা আমি তাহলে তোমার বলছি আমি ওই যে ফাইনালের থেকে কাউন্ট করে নিব আর কি। ফাইনালে তো দিছো নাকি? ফাইনালে দিছো না ভাইবা?
ফাইনাল বলতে
তুমি দুইটা ভাইবার মধ্যে কোনটা অ্যাটেন্ড করছো, মিড না ফাইনাল?
স্যার ফাইনাল অ্যাটেন্ড করছিলাম, মিডে স্যার অ্যাটেন্ড করি নাই।
কেন?
স্যার ওই যে ওই দিন স্যার আমি হাসপাতালে ছিলাম, আপনাকে নক করছিলাম।
হ্যাঁ, আচ্ছা। ডিএসপি তোমার রোল হচ্ছে 8 না?
জি স্যার।
কোর্স তো তোমাদের দুইটা ছিল, ডিএসপি ছিল, কমিউনিকেশন ছিল।
জি স্যার।
এরপরে কিন্তু আর মানে শনিবারের পরে আর টাইম আর ঠিক করা হবে না, শনিবারে ফাইনাল একদম ফাইনাল দিয়ে দিব।
জি স্যার।
Okay, so today we'll one thing I will forget otherwise. What about quiz? We should take a quiz. Okay, quiz time for the final, because at the end you got some rush. So I think before ending the course I should take the quiz. One quiz already done, right?
Yes sir.
One quiz done, so one more quiz left, which is based on the final syllabus. So I think chapter 5, 6. Okay, one or two more after finishing one or two more chapter, then I'll take the quiz. Okay. In the meantime, you take the preparation for your presentation. Okay. You know every semester you have to give a presentation. So you take the preparation, which topic you should give. Okay. Presentation time. So when is better, which time is better to take the presentation? Do you have any suggestion? Yeah, Abdi Hamid.
Yes sir. I think 12 January, July.
July.
Yeah.
12
Middle
July.
of July.
Mid of July.
Yeah, that's good time.
Okay, that means 2 weeks later. After 2 weeks. Okay, Hamid, do you have any suggestion?
Yes, around July, sir.
Around July, mid of July.
Yeah.
That means before the Eid vacation.
Yeah, inshallah.
Okay, before
Yes
the
sir. Yes sir.
Okay. So take your preparation mentally. That after 2 weeks we'll take the presentation.
Oh, thanks, sir.
Okay. And
Okay,
the
sir.
quiz. Second quiz will be first week of July.
Okay sir.
Okay. That means after the next week. Okay. Next week is the last week of the June. After that, we'll take the quiz, second quiz. So before the Eid, we should finish everything. Okay, so that is our plan, because Eid vacation will be started, I think, around the mid of July, because 21 of July is the Eid ul Adha. So we have to finish everything before that. It's possible, not impossible. Okay. So that is our topic, which is the control system stability. So far we have finished few chapters like introduction, chapter 1, chapter 2, chapter 4, and chapter 5. 4th chapter has been finished. Now one more chapter left, which is the chapter 3. I will come to that chapter very soon. But before coming to that chapter, I would like to finish a few more easy chapters. Okay. So, control system stability. So what we'll focus on this chapter, we'll focus on the few things like design objective, focus on what? So if you would like to design anything, then you have to focus on few things, like you would like to produce the desired transient response, you would like to reduce the steady state error, and you would like to achieving the stability. These are the basic criteria of producing the desired transient response. Okay, this is the basic criteria. Now, so first of all, you need to get the desired transient response. So do you remember what is the transient response? Transient response is like that, something like that. That is a transient response. Okay, that means after a certain time, it would be stable. Okay. Let's say that is the margin, this margin. Okay, so some steady state error are there, some error are there, and you need to get a stability. Okay, these are the things you have to consider here. Okay, let us discuss about the C. What is C actually? Do you remember C? So say that is R, yes, that is CS, that is transfer function. Okay, so C is the output, right? C is the output of a system. Whenever you give the RS as the input, then you will get the CS as the output. So that is the output. C is the output of a system. That is a system. Now, you can divide C into two parts. One is forced, and the other one is natural. C is equal to, see here, one is forced, one is natural. So can you distinguish between this? Force means what? After you giving the input, that means you are giving the input R, you are getting the output CF. So if you do not apply this input, then you will not get this output. Okay, so that is this output, this C is forced. Okay, and another one is natural. That means it will occur naturally. That is the thing. So is output of a system, which is C, which can be represented as C, can be divided in two parts. One is C forced and another one is C natural. That means forced response, and another one is natural response. Two response. Okay. So forced response and natural response. For a bounded input, depend upon natural response, the system can be stable, unstable, or marginal. So see, so system can be stable, unstable, or marginally stable. Okay. So a system is stable if every bounded input yields a bounded output. So we'll see this later. If input is bounded but the total response is not bounded, the system is unstable. So we'll see the stable, unstable, marginally stable systems few moments later. Okay. Now look at the stability. Okay. First of all, a system is stable if the natural response approaches zero as time approaches infinity. Okay, see, a system is stable. So if I ask you which one is a stable system, so what would be your answer? A system is stable if the natural response approaches zero. Natural response means what? C natural. If the natural response approaches zero as time approaches infinity. So natural response should be zero as time reaches infinity. Okay. That is a thing. That is the stable system, criteria of the stable system. And which kind of system is stable? See, let me show you this one. This one is stable system. After a certain time, it becomes stable. System is stable if the natural response approaches zero as time approaches infinity. As the time approaches infinity, after a certain time, it becomes stable. Okay. A system is marginally stable if the natural response neither decays nor grows. A system is marginally stable. Marginally stable. See, a system is marginally stable if this natural response neither decays nor grows, but remains constant or oscillates. What kind of system it is? That means a system is marginally stable if the natural response neither decays nor grows. That means, let me draw. This kind of system. Let me draw it clearly. This kind of system is the marginally stable system. See, it does not grow, or let I have a call. I have to take this. Okay. So that is the marginally stable system which does not grow or does not decay. Neither decays nor grows. This kind of system is known as the marginally system, marginally stable system. That means that is the response of the system. Unstable system is what? If a system is unstable, if the natural response approaches infinity as time approaches infinity. So this kind of system, see, it approaches infinity, it will grow. So it will be like this. Okay. It will be like this. Okay. So that is the stability. Three kind of stability are there. A system is unstable if the natural response approaches infinity as time approaches infinity. ঠিক আছে? So three kind of systems are there. System responses are there. Okay. So one thing is a system is stable if the natural response approaches zero as time approaches infinity. A system is marginally stable if the natural response neither decays nor grows. Okay. But remains constant or oscillates. A system is unstable if the natural response approaches infinity as time approaches infinity. A system is unstable if the natural response approaches infinity as time approaches infinity. System is marginally stable. So remember, we can divide stability into three categories. First one, stable system. The natural response of the system would become zero as time approaches zero. It would be the stable system. And in the marginally stable system, the response does not grow or does not decay, but remains constant or oscillates. That is the marginally stable system. And a unstable system, a system is unstable if the natural response approaches infinity as time approaches infinity. Okay. So I think you understand this. Now important
sir.
one. Okay, so you understand the stability types. Three kind of system: stable, marginally stable, and unstable.
Yeah.
Okay, remember this. This is very important to understand the response, output response of a system. Okay. Ruth-Harris criteria. Ruth-Harris criteria, that is another one. By using this method, we can tell how many closed loop systems poles are in the left half plane, in the right half plane, and on the j omega axis. Okay. So see, by using this method, we can tell how many closed loop system poles are in the left half plane, in the right half plane, and on the j omega axis. The method requires two steps. Generate a data table called a root table. Interpret the root table to tell how many closed loop system poles are in the left half plane, the right half plane, and on the j omega axis. So first of all, we have to generate a data table called a root table. Okay. So by using this method, Routh-Harris criteria, we can tell how many closed loop system poles are in the left half plane, in the right half plane, and on the j omega axis. So this method requires two steps. So first of all, you have to generate a root table, and in the second step, you have to interpret the table. And by using the table, by looking at the table data, we can tell how many poles are in the right half plane or on the j omega axis or in the left half plane. As you know. So we already know these kind of systems we have seen in the chapter 4. Okay.
Yes, sir.
So generating a basic root table, that is very important. See very carefully. If you do understand the basic, then you can easily generate the root table and interpret the root table. So since it is online, so it is difficult actually, but I am trying my best to give you the understandable idea. So see, this is what? This is a transfer function. That is a transfer function. Okay. That is a so here the denominator. Look at the denominator. This one. This one the denominator, right? A4 s to the power 4 plus A3 s cube plus A2 s square plus A1 s1 plus A0. Okay. Okay. So here, look at the figure, look at the equation. From this equation, that means the denominator, from the denominator of the transfer function will generate a root table. So how to do this? A4, see, first of all, see, in the left half plane, in the left side, you put the power of s. S to the power 4, s to the power 3, s to the power 2, s to the power, s to like this. This is the column of s. Here you will put the coefficient of the system of the line. How to put this? First one, A4. A4. Then you skip the second one, go to the next one, A2. Then you skip the second, very next, then move on this, A0. Then in the second line, that means there's 3, A1, sorry, A3, A3, A1, and here 0, 0. Look like this. Okay. Now, how you will put this line? S square, S1, S0, these values. There is a technique. It is what? A4, A3, A2, A1 divided by A3. Minus would be there. And for the second one, A4, A3 will be fixed and A0.
Excuse me, sir. Hello.
Yes,
1 minute. Wait 1 minute. عبد الحميد وصاحب مود صار عبد الحميد.
Abdul Hamid, what happened?
Please mood. Yes. Okay. You can go, sir. Thank you.
Okay, okay.
Sorry.
I think Hamid in the kitchen is doing something.
Yes, yes, yes.
Okay,
Yes, next side's my building. It's going on.
okay. Some work is going on. Okay, mute yourself. Okay, now see the root table. That is the formula. Do you have the book? Do you have the textbook? Have you bought it? Or I think I give you the soft copy already. Moreover, I'll give you the
Yes, we
slide.
need software, sir.
Yeah, you have the soft copy in the classroom. Okay. Now see how to generate this row. The first column minus A4, A3, A4, A3. Very next column A2, A1, A2, A1, and divided by this one. That is the B1. Okay. So that's how you can find out the first value. Now for the second value, first column would be same A4, A3, A4, A3, and you will skip this one because you will look at the very next column A4, A0, and 0 divided by first one A3, which is B2. Same. And for this one, third one, minus would be there. First column A4, A3, and skip this one and then look at here. Definitely that would be 0. That would be 0. And here the value A3. for this here, for this line, minus A3 and B1, and here A1, B2, A1, B2, B1, and this C1. For the C2, A3, B1, 0, 0 by B1. Okay, like this, you have to generate the table. That is the way to generate the table. Now we'll look at the problem, look at some examples, then we'll understand more. Okay. Look at the figure, the question here. Make the root table for the system given below. See, that is the root table. Here is the root table is given. Sorry, here that is the system is given. Now you have to find out the root table. So what you have to do? You have to reduce the system here. Matrix is there. So the system would be, you have to reduce the system 1000 I think that there would be 1. Since it is minus, so it would be plus. S plus 2 S plus 3 into S plus 5. So what would be the question? So just calculate S square plus 3S plus 2S plus 6 multiply delta S plus 5. So it would be S cube plus 5S square plus 15 S plus 3S square plus 2S square plus 10S plus 6S plus 30. If you multiply it, so equation would be here there would be 1000. So S cube for the S square, 5S square, 8S square, 10S square plus 10S square plus S for the S, 15, 10, 25. and 6. $25, 15s, 6x. That means 31. 31x plus, for the s to the power 0, that is 30. So if you add this one, the thousand, so it would be become s cube. That is s cube. S cube plus 10s square plus 31s plus 1030. Now you have to multiply it. Now you have to use this denominator. Now see, for the s cube, that is 1, 31, 0. And here the 10, 1030 and 0. Now reduce the thing. Okay, so that is the way to develop the root table. And now see here another thing, that how to interpret this line. Okay, let me show you. For this one, 1, 31, 103. Divided by what? Divided by 1. So 103 minus 31. That means 72. So minus 72 by 1. 1 is 1. It will be minus 72. And similarly for here, that would be 1. Not 0, that would be 1. There is a mistake in the book. That is 1, 0, 1, 0 by 1. So it would be 0. So similarly, 1, 1, 0, 0, it would be 0. For here, 1 minus 72. 1 minus 72. And here 103, 0. 103, 0. And how divided by minus 72. So this equation becomes 100 minus minus 72, that would be plus minus 72 into 103 minus 72. So only 103 will be remain. Here, 103 will be remain. Okay. Similarly here, 1 minus 72 0 0 divided by minus 72. Okay, so it becomes 0. Like this, the table will be developed. So here the way to develop the root table. Okay, so interpreting the root table. How to interpret this one? Okay, how to interpret the root table? We know how to generate the root table. Let us see how to interpret it. The basic root table applies to system with poles in the left and the right half planes. System with imaginary poles and the kind of root table that results will be discussed in a session. So stated, the root harvest criteria declares that the number of roots of the polynomial that are in the right half plane is equal to the number of sign changes in the first column. See, the number of roots of the polynomial that are in the right half plane is equal to the number of sign changes in the first column. So you have to look at the sign changes in the first column if you want to find out the root, the right half plane. Okay. So in this figure, in this one, how many times sign changes? Twice. Here the first column, that is the first column. That is the first column. That is the first column. And in the first column, how many times sign changes? Twice, I think. Here from the S2 to S1, plus to minus, and S1 to S0, minus to plus. So 2 root will be in the right half plane. See, a system is stable if there are no sign changes in the first column of the root table. 2 sign changes in the first column. The first sign change occurs from 1 in the S square row to the minus 72, and in this 1 row. The second occurs from minus 72 in the S1 row to 103 in the S0 row. Thus, the system of the figure system 4 is unstable since 2 poles exist in the right half plane. See, so how many poles are there in the right half plane? 2, because there are two times sign changes occurs in the first column. So the system is unstable. So from the root table, you can define few things like if the system is stable or unstable. Okay, or the how many poles are in the right half plane or in the left half plane. Okay, I think this one I'll show you in the next class. 0 only in the first column. Yeah. So far, is it okay or not? So far, you understand, guys?
Yes, sir. We understand.
Yes, sir, we understand. Yes.
Okay, so we have seen how to generate the root table and how to find out the poles. Okay, so in the next we'll see some special cases are there. According to that special case, you can change the pole. You can interpret the table. Okay, a few more things are there, so I cannot move further because it would be difficult for you to cope up. right? Because high level of concentration is required in the coming topics. So I am not moving forward. I am stopping here. So that is the basic root table criteria. Okay, let me take the attendance.
Okay, sir. Okay. Okay, sir. Thank you so much.
Okay, roll number 1, 3, 8, 14, 18.
Yes, sir.
12,
Yes, sir.
12, 17.
Abdi Hamid,
Yes, sir.
roll,
17.
roll what?
Roll 17.
17.
Roll 17, sir. Yeah.
Yes, sir. 14.
Yeah, 14, I write.
So roll 8.
Roll 8.
12, sir. Roll 12. Paro.
12, yes.
Okay, sir.
Okay, 1, 3, 8, 14, 18, 12, 17. Yes.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So, okay, what about the lab? Have you installed the MATLAB?
Yes, sir. Yes, sir.
Okay. Can I show you something today?
Yeah, today.
I'm not. We have no laptop now, sir. I'm going to take visa. I'm applying visa today.
Yeah,
I'm
here.
not. Yeah.
Okay. Okay, we can take the multiple lab classes one day. No problem.
Okay, sir.
Okay, it's
Okay, sir.
better you come to the Saturday or the, no, not this Saturday, come to the
Tuesday.
Tuesday to the
Okay.
campus.
Okay, sir. We
Okay,
are.
sir.
All right, sir.
Okay, that will show you, inshallah.
Okay, sir.
Okay.
Allah
Okay,
Hafiz.
okay, Allah Hafiz.
Allah Hafiz.